we're going to present our work. The objective is to share with you the results that we have achieved, the experience we have gathered during the execution of this project, and probably this would help the rest of the data partners or the colleagues that attend the session to also, as a team, achieve also better results. So in the beginning, I'm going to represent the team. It's not only me. We are a team with a lot of experience in this area, not just from the past year. Together in the team, I worked with representatives from the Medical University of Sofia, presented by Professor Dimitar Cherekchiev, by introducing also Evgeniy, who's been the manager of the project, and our PhD students, Emanuil Markov, who is going to present a little bit later, Petko Kovachev, and Simeon Abanos. In the beginning, I'm going to introduce with a couple of words Bulgaria. It is on the eastern part of the country, situated in the northern part of the Balkan Peninsula. It is bordered by Romania to the north, Serbia and North Macedonia to the west, Greece and Turkey. You can see here the map in the lower left corner of the screen. So to the south, we have a common border with Greece and Turkey, and the Black Sea to the east. Bulgaria covers a square about 110,011, let's say, square kilometers. It is one of the actually smallest countries in the region, 16th largest country in Europe. Where Sofia is the nation's capital, and the largest city are like Sofia, Plovdiv, Varna, and Burgas. The history of our country comes from the ancient times, and humans have lived in this area that is now Bulgaria for thousands of years. The region was once part of major empires throughout the history, including the Byzantine and the Ottoman empires. Evidence of human habitation in the area of Bulgaria dates from ancient times, as I said, and recent archaeological discoveries recovered the oldest processed gold in the world, aged about more than 6,500 years ago. So one of the major things in history that we are proud of is the Cyrillic alphabet that been created by Saint Cyril and Methodius around 1,200 years ago, and it is the language we speak now and write in not only in Bulgaria but in some of the surrounding countries, including Russia. So the spread of education was in fact the centerpiece of the Bulgarian national revival. And Sofia University, that you see on the right upper corner of the screen, is the first Bulgarian high academic school establishment. It was founded in the year 1888. We are proud to know that the inventor of the first digital computer, Professor John Atanasov, working while at the Iowa State University in 1945, is of Bulgarian origin. And Bulgaria is also internationally known for the Thracian treasuries by its seaside, the spa, mineral spring water, and the winter resorts like probably you have heard about Bansku, Velingrad, Nesebr, Suzopol, Albena, of course, also for high quality wine, rose oil, and tasty food. So according to the latest national population census in 2021, the population of Bulgaria is around 6,005,000 people. And here we can note that about 5,000. Most of the people live in towns, about 73%, and a smaller number, about 1 million, let's say 2 million, live in the villages. So here on this map, you can see, and this is important for what I'm going to show you later on, the map of Bulgaria, where in dark green you can see the areas covered with where most of the people that are of elderly people live. It is in the northern part of the country, while the younger people live in areas where with let's say higher socio-economical factors, where the life is more intensive. And this is in close relation with the prevalence of diabetes. You can see later on that from the data we have, these regions are populated with people that are most of the people suffering of the diabetes illness. So the topics I'm going to discuss today are structured as follows. First, I'm going to say a little bit more about the background we have in the research related to data, related to gathering clinical data. Then I'm going to speak about the data source harmonization. It's an important issue related to health data quality. The center of the presentation is how we have gone through the process of the ETL, and a special side of our project has been that most of the clinical data has been extracted from raw natural text language. This is something that I want to emphasize, and I'll make a conclusion and open the session for questions. So the objective of this presentation is to share with the EDEN community the experience and the skills we have acquired in our work, and of course the problems we have encountered and how we have resolved these issues. So nothing happens out of nowhere, and especially the terms and the resources of these projects are strictly when the terms, the constraints on time and resources are strictly defined. Therefore, in the beginning, I'll briefly describe the clinical data assets used in this project and the preliminary work, because we had to do a lot of work before the start in advance of the project. And this also determined how later on, more or less smoothly, we moved through the stages of the project. So there is something specific to the Bulgarian data, the collection of clinical data, that our national health insurance funds, by law, by legislation, collects documents containing clinical data, and primarily this data is accompanied by accounting information. So all of the healthcare data, healthcare providers direct for accounting purposes, most of all, reports to the national insurance funds that are used primarily for auditing, for financial purposes. However, inside these documents, you see the data practitioners, the medical specialists, pharmacists, laboratories, all the participants in the healthcare process are reporting to the National Insurance Fund. It is a pity, I would say, it is a problem that this information is not publicly available, and this data collected from different participants in the healthcare process are stored just in the National Health Insurance Fund. And these documents are structured as XML documents by format, XML scheme defined strictly by the National Health Insurance Fund. on one side, it is good. However, most of these participants use software providers that in a different way implement these documents. And as we're going to see later on, the XML documents, although they satisfy a given format, their contents in terms of natural text, when you have to analyze the anamnesis or the examination, you find there arbitrary collection of data with all kinds of abbreviations. This complicates a lot our work to extract this kind of data later on. So despite the primary accounting purpose of these records, we managed to collect using the goodwill, let's say, of the Ministry of Education and Ministry of Health, some of these documents during the years. And in our work, we have collected documents for the period 2011, 2011, and 2019. These are the documents that we have. So most of the time, people witnessing our presentation asking, are there no more fresh data? Unfortunately, no. This is the latest data that we have at our disposal, 2029. This is the latest data that we have, not only in our database, but also in Bulgaria, that is publicly available. So although this is kind of a limited period of time, this database, the database Bulgarian Diabetes Register, contains records for more than 7 million citizens, as we say here, and it includes, it refers to about 503,000 patients with diabetics. It is also publicly available, so I've given here the link to this register, so everybody interested can log in and search and get information like the one displayed here on the screen. And this is one occasion to note that if you compare this, this map of Bulgaria with the previous one I have shown, you can see the more darker red color in the north, showing that the prevalence of diabetes is in the regions where the elderly people are prevalent, that prevail, the percentage of the people with older elderly people are more than the rest of the population. So what are the important elements in this structured data? You can see here administrative data. Of course, this is something we notice in the CDM model. The diagnoses are given in ICD-10. And of course, it is good that the National Health Insurance Fund maintains drug codes that are both reimbursed or non-reimbursed. We have information for all these kind of drug codes, and they are convertible to international standards. This is good. This has been a good occasion for our mapping process. Encodings also for examinations and procedures can be found in these documents. For instance, codes describing specialized health care, or codes specialized describing need for hospitalizations or planned consultations, lab tests especially, this is very important, or medical imaging. Because we speak about XML documents, contain valuable information hidden in natural text. Unfortunately, this natural text, for which normally there are well-developed NLP tools, cannot be applied directly to our case, because for Bulgarian, all the text is written in Bulgarian, and it complicates a lot. So we have here a couple of fields in our documents that contain valuable, rich data related to, for instance, clinical data about blood sugar, blood pressure, for instance, height, weight, body mass index, glycated hemoglobin, and so on. Also, data related to clinical examinations and the investigation, the extraction of data from natural text is complicated, as I said, because this natural text is written in plain Bulgarian, although using a lot of abbreviations and in arbitrary order. It complicates a lot the application of the available. There are a lot of such NLP tools around, but they are not directly applicable to this case. And we have found, of course, a way to overcome this problem. So one important issue of the preliminary work we have done is data source harmonization. As I mentioned, outpatient records, and these are actually, this is our primarily data source for we mapped onto the OMOP data CDM model. They are not provided on a regular basis. They are obtained after pseudonymization procedure, and this is actually a requirement by law. The problem is that in our case, this procedure introduced readability programs in our data files, these XML although text files. Because of the pseudo-anonymization, it introduced a lot of control symbols that a large document, for instance, of 10K, you can see just one screen of this file. Also, if you introduce inside the XML document, for instance, the and sign, together with the greater than sign, it complicates the validity of the whole document. So we had to exert a lot of effort to apply and to harmonize the data source before the start of the ETL process. The difficulties, in summary, are as follows. Provides documents. First, as I said, the documents are provided by the National Health Insurance Fund on an irregular basis. And the pseudonymization with respect to personal data, age and gender, visit-related information induces a lot of errors in these data files. For instance, the binary codes we had to deal with, they are invisible in most cases, and we have to find a way to overcome this case using Java applications to go through all these files and to restore actually the XML format and model that we used to have to represent this data. So the problem solution, as I said, has been twofold. First, we had to deal with a large number, extremely large number of data files. Each of them has been a large file, so it is not so easy to deal with such files on our computers. So we have to create programs that will read portions of these files and process these files, let's say, in chunks, each that is easy to manage. And the restoring also the data file to an XML model is also not so easy to implement, but we can overcome this problem as well. So I draw your attention to this fact because in our experience, and this want to underline, the efforts to convert this pseudonymized data to a formal XML scheme or to a relational data model is an important condition for generating reliable evidence. This is an issue that we discussed together with Professor Cheragchiev. We were one of the few, if I remember, together with Naiche on the latest Health Data Forum we attended in Porto. And the quality of health data can be really is very important to maintain health data quality if you have your data converted and presented in a formal model like the one we used in our work. So what you get as a result, you get a source, data source that supports the FAIR principles. In short, these are findable, accessible, interoperable, and reusable data. This is easy later on to smoothly follow the steps of the ETL process, as everybody in the community knows. And moreover, we work in our group intensively on applying semantic interoperability in clinical data exchange. So in case your data satisfies the requirement of a formal data model like a XML scheme or a relational database, then you have the ability to implement international standards for semantic interoperability in clinical data exchange. Here I will stop for a while and give the word to our PhD student Emanuil Markov to continue with the part that he's been more intensively involved during the project. It is about the ETL, the stages of implementing the ETL process. So, Emanuil, please continue.
Thank you, Professor Krastev. Hi, everyone. I will start with saying a few words about the infrastructure that we are using for hosting all the tools and services that we needed. So we had luckily super micro workstation with two Xeon processors and kind of enough amount of RAM. We used SQL Server Developer Edition as on which we were able to use as Academy. Then the standard Odyssey tools like R 4.2 and RStudio and Web API Database Connector. And of course, the standardized tools like White Rabbit, Rabbit in a Hat, and later on Atlas on top of the rest of the packages. So a few words about some of the most important vocabularies from Athena that we used to map our data. So first and maybe most important is the ATC classification for the medications, Medicare specialty codes for provider specialties, then international classification of diseases, 9th and 10th revision, respectively. 9th revision was used for procedures and 10th revision for diagnosis. And we used also SNOMED for mapping the measurement types. So here you see again which primary data was mapped to which dictionary. Then regarding the table migration schema, you see on the left-hand side the somehow represented the structure of the source database that we managed to extract from the XML files that were then mapped step by step and transferred to the OMOP Common Data Model version 5.3. So first of all, we mapped doctors' care sites, locations, then patient data, then ambulatory lists. From the ambulatory lists for diagnosis, and on top of that, we get measurements, and procedures and prescribed drugs. The data transfer itself was script-based directly from database to the other database. Like to create the OMOP database, first step was to load Athena dictionaries. Then we filled the country location tables. And after that, we started with loading primary data tables like care site, providers, persons, and observation periods, followed by visits, conditions, drug exposures, measurements, procedures, and finally we run the scripts to generate the derived tables like condition and drug error. So what's the data that we currently have available converted to OMOP? Like Professor Krastev said, around 500K patients. You see the distribution here of male, female, around 16.5 million of drug exposures, nearly 7 million visits, 70 million measurements, 20 million registered conditions, around 500,000 procedures. And this is only for the observation period of currently of 1 year that starts from that covers the year 2018. And on the left-hand side, you see the distribution of also of the extracted measurements through the NLP algorithms. Here you see some information about patient's age. So normally for diabetes patients, majority of patients with diabetes are over 60 years old. Then year of birth, you see quite a wide range, which makes sense because the register covers nearly 99% of the population. Then records distribution, a lot of records for conditions, visits, drug exposures and measurements, and a relatively small proportion of procedures registered. Most common types of visits registered, 4.6 million general practice visits, and then we have of course endocrinology, cardiology being as mostly visited specialists, and then the rest. What were the main challenges that we also faced during the ETL process? Kind of, we had to select ourselves. Basically, since there is no clear guidance, or at least we weren't able to find which dictionary to use. After all, we selected those that are being closer to the data that we have. For example, for measurements, we didn't have a recommendation whether to use SNOMED or WOINC, so we preferred to use SNOMED. Also, we had some issues that our SME helped us around configuring web API at Atlas, since most of the documentation is available for PostgreSQL Server, and there are not enough examples how to configure Microsoft SQL Server on the documentation and tutorial sites. Also, the scripts that we found, especially for drug error creation on the ODC site, did not work for our database, since our drug exposures are coded with ATC, while the scripts that was published on the GitHub site was using RxNorm to build the Drug table. And again, the SME provided us a script that kind of made internally the conversion between ATC and RxNorm components to create the Drug table. And the final issue that, to be honest, I don't know who resolved it, but when we published the database dashboard on the Eden portal, it was presented totally empty. While a few days later, we saw the dashboard filled correctly with all the data. I don't know why this happened. So that's so much from me related to the ETL, and I'll hand over back to Professor Krastev.
Yeah, thank you, Emanuil. You can hear us again, right? So to continue from what in a summary, it's been a very good idea to work together with a SME, and without the experience, as we have noticed, experienced guidance by our SME. It is medicals come from Hungary. I'll mention especially in the acknowledgement their role in our work. We would have a really difficult time. At the same time, our team is really proud that at the Eden site, our project, if you note all these 5 indications for the project completeness, we have 100% executed all these items, and I repeat, we are proud to have achieved this successful completion of the project. So one of the most valuable elements in our work has been to add measurements to our data, the one that we have converted to the Eden community. And therefore, in the remaining part of our work, I'm going to show you some evidence for how we have extracted work from this project. So just a moment, let me see if I have this presentation, because it is still anyway, probably everybody sees this presentation. It's still from Emanuil's computer. So the XML data file contains elements with free text. These are anamnesis, patient care, examination, and prescribed treatment. And all of these contain valuable clinical data, especially in the parts of the anamnesis, the patient state, and examination. What makes them valuable in our case is that these are national representative elements. For instance, in most of the reports you can see around in the existing literature, you find measurements that are around 2,000, 3,000, but here we deal about hundreds of thousands of measurements, and they are valid nationwide. So first of all, they are easy and credible for statistical research. It is one thing to have about 500,000 and another to have 3,000 or something of this sort. And second is that these are national representative samples. Another very special feature of these measurements is that they have been extracted from raw, unedited clinical documents prepared by doctors, by healthcare specialists. if again you compare in the existing literature, most of the data sources are compiled from questionnaires, something that a patient has, for instance, entered the data. And in our opinion, this is not so creditable as when the documents come from the hands of a doctor, somebody that is professionally treating, observing the state of a patient. Otherwise, here on this slide, you see most of the elements that you have seen in the presentation of Emanuil. And one thing that you have not seen there is the diabetes illness duration. This is another measurement that we managed to extract after the end of the project. And this is especially valuable because it allows to analyze the effectiveness of treatment during the years. For instance, for treatment, for instance, the application, and of course, the relation of the treatment of diabetes with respect to the rest of the measurements that you see here displayed on the screen. It allows you to turn into a quantitative numeric format all these usually conclusions that are presented in descriptive textual format. Here we can convert all these in terms of numbers when you have the diabetes illness duration in years. We have made a couple of publications. In fact, in the last year, if you count the one we have made in the last year, 2 of them, and one of them is during the ICMTH conference in Greece last year in July, and it was about the data measurements in body mass index. And here on the screen, you can see some of the slides that we have presented on this conference. You can see here, these are the first results that we are actually just so, we have just so extracted the document, the data, and we couldn't go into deeper analysis of this data. So here you see the age groups, how diabetes is spread, and of course the BMI for those of the people that with diabetics. And we notice that the BMI factor is important to influence the diabetes illness later on during the year. So first you observe a higher BMI, and then you see the results in diabetics. What I want to summarize at the end of this presentation. First of all, as I several times had the occasion to repeat, that makes it valuable is that the data converted to the OMOP CDM model is a national representative sample of outpatient records. This is very important to underline. And unlike other data that is collected in and converted through OMOP CDM, here we speak about data recorded from native pseudo-anonymized outpatient records, and the measurements represent a valuable resource for research analysis of the diabetes illness. Again, I want to reiterate that we made a lot of effort to validate the data that is mapped and to maintain high data quality of data, and this way to ensure that the analysis, the results will be repeatable and creditable among all the organizations that might use this kind of data. For future work, we have a lot of potential accumulated during this project, and we have not only the skills but also have the resources. As I mentioned in the beginning, we have data for a period longer than 5 years, and we with this experience, we plan to extend the scope of the measurements related to diabetics, diabetic illness that are hidden in the elements, the data elements presented in free natural text. And this way, we can, of course, be glad to be involved in future EDEN research-related projects, and of course, not only for science, but also with applied nature. Here you can see the two publications that we delivered on two conferences. Of course, we have some more, but these are especially related to the EDEN project. So whoever is interested, here you can see they are already published, and you can get the text from this slide. At the end, I cannot finish without mentioning a gratitude, a special thank from our team to our SME partner, Medical Scan from Hungary, especially to the director of this organization, Celia Blasauer, and of course to their senior developer Gabor Forás, who has been really helpful, as Emanuil mentioned several times during the project. It's been invaluable. He's invaluable, the help he has presented to our team to complete the stages of the project in time. And I cannot also forget to thank personally to Naic, who has encouraged us to deliver this presentation, and of course Montse for her kind support during all the stages of this project. Of course, here it would be nice that we hear from you your comments or questions regarding the presentation. Otherwise, whoever would like to contact us, here are the emails of Professor Cherchiev and my email. Whoever wants later on to approach us for further and more detailed information. Thank you for your attention.